You're alive. Yay. Morning, everyone. How are you? New Rust release tomorrow. One interesting thing that I saw in the new Rust release is build directory configuration. Wow. This is a lot of desktops for no Chrome windows. Drag a Chrome window over here. No browsers. Releases.rs. So 191, I think. Yeah. October 30th. That's tomorrow. I don't know if I'm going to do a video on this. I used to do Rust language videos, like release videos. There isn't really all that much in them. So I don't know how useful they are. Right, couple of new targets, worn in a couple cases. AR64 PC Windows MSVC is tier 1. Couple others got tier 2. Document assumptions about clone and eek traits. Most standard library collections break if clone is non-standard implementation, which violates x clone equals x. Bunch of stabilized APIs. It's peanut butter jelly time, but with Rust and Bevy time. Yeah, I mean, the guarantee parameter order for the bivariance of min-max and min-max, like, I don't know if there's much to talk about here. Like I said, stabilized APIs. The stricts are interesting. Where is, let's go strict rem Euclid. It's like an issue if you do the minimum possible value over -1 on a signed type. So strict rem Euclid can help in that case. I guess chain, which is cool. Partial equality for strings and paths. Couple of sum and product implementations for the saturating numbers. And then another stabilization of extract if. Extract if is already stabilized in other cases. But the thing that I was interested in is the builder for cargo. So this is a stabilized configuration. Sets the so basically target is going to be for build artifacts. You're so appreciative of my general Rust series. I hope you do more. That is today's stream. It's right here. We'll get back to it in a second. This is the Rust release tomorrow is what I'm taking a look at right now. I think the most interesting thing for me is that the split of the target directory is now only build artifacts. And then there's a potentially separate build directory. The doc links to the current docs. So because this isn't released yet, this link doesn't work. But there's a couple PRs. The target flag can now take triples, which is cool. This is documentation update. So stabilizes builder. So now intermediate build artifacts are no longer going to be in target dir. I don't know what the default for build dir is. So I don't know where this directory is going to be. These are all implement builder. So this is the PR that implemented it. This is one of the really nice things about Rust too. For the releases, you can just be like, oh, this is the PR that went into the repo that did the thing. Final artifacts are binaries, .crate outputs, etc. Cargo doc output, timings, HTML reports. So if you do a Leptos app, I think that still sits in Target at the end of the day. If you do a Bevy CLI web build, that also sits in Target at the end of the day. And then things like build script output sit in this build directory. rlibs, any kind of intermediate artifacts. Builder is likely going to be set by users globally. So tomorrow, I think we'll have a stream. We might have a stream tomorrow. I don't know. I haven't decided yet. But after Rust 1.91 comes out, the first thing we do in our first stream is probably going to be the set this builder, which is really cool because I do a lot of the same kinds of projects, right? I do a lot of Bevy projects, or if I'm doing like Leptos, it's a bunch of different Leptos sites, etc. So a lot of the build artifacts can be reused. For users that multiple cargo versions, I'm guessing for users that use multiple cargo versions, for users that multiple cargo versions having an error would be disrupted. For users that multiple cargo versions having an error would be disrupted. For users that use multiple cargo versions, I don't know what the sentence means. I was really trying. I don't know what this sentence means. Something about multiple cargo versions and errors. I assume that the builder then has to be set per cargo version or something like that. I don't use multiple cargo versions all that often, so maybe this resets when I upgrade cargo, which would mean resetting whenever I switch Rust versions. That's interesting. Having a builder per cargo version. You know, sometimes you just write something and you think you wrote it and you miss a word. It's happened to me. Happens to me many times. I write many words. Happens to me in videos. I just I don't know what this means. I think it means that if you switch Rust toolchain versions, that the build directory has to be different. I think that's what that means. The fallback behavior is to revert the behavior of the current stable release, which is the cargo targeter. For this PR. This is only the one of the 5 PRs that went in to make this feature. Cargo clean only cleans target and doesn't impact builder as of this PR. Where do a bunch of different things go? Do we want a cargo builder, shortcut nvar? It should clean the builder. I think I don't know that I agree with that. If you cargo clean in a project, the builder is likely going to be set by users globally, i.e. cargo, home, cargo, tomo. So this is what we'll try to do. We'll try to do this. We'll try to build a couple projects, see if it helps. I'm interested in what happens if you have multiple projects with similar dependencies that have different flags, things like that. But this is my most kind of exciting 1.91 change that I'm currently aware of. Restrict the scope of temporaries created by the macros. Yada, yada, yada. Yeah. Cargo published no longer keeps .crate tarballs as final build artifacts. When build.builder is set, these tarballs were previously included due to an oversight. Okay. That's cool. Tools and projects relying on the internal details of builder may not work for users changing their builder output. So this might be a thing. This might be a thing for certain projects. Like it might not work for, let's say, Leptos, because they have a couple of different folders in the target directory. They have one for like the server, one for the front end, etc., and then one for the target output. So Cargo Leptos might need to change to support this, but like a regular Bevy project should be fine. But yeah, that's Rust 191. I don't know. I think maybe I do a short on the builder stuff. Maybe I do a short on a couple of the other functions and stuff, but I like that they do a release train. I like that we get a release every 6 weeks, but it does mean that the release every 6 weeks is just kind of like whatever merged, which is not always like show-stopping stuff. So we are in, let's see. This is quickly becoming an entire book for our Rust language content, which is slightly concerning because the content that we're actually actively writing right now, I want, this is in temp, right? Yeah. The content that we're actually writing right now is something that I want to be a reasonably short video. Like I don't want to do a 2-hour video. So I might have to do an editing pass on this after we're done. I think with that in mind, we're about to get into some error stuff. I think covering levels of error handling might be the wrong way to like describe this, but covering the levels of error handling is really what I want to do. Right? Like levels of error handling, like lib versus application. We're going to kind of talk about like how to add a dependency, I guess, in this section. See, the heading that we're under here is building our own errors. I don't know that we want to flow into that. Let me see what we're at. I think we're at like 60, 64, 6,500 words here. So let me just WCW Rust quick start source main. This is all of our content. So we're at like 6,400 words. 6,400. What was it? 150 is the normal speaking pace. So it's still 42 minutes of video. We're really going to have to do a YouTuber speed run through the content. And we're not even really done with the content. So I think that reflecting on what we wrote about structs and stuff, I feel like the structs and primitives section was a little bit syntax heavy. I don't know that we can get away from that because structs and like you got to talk about the syntax at some point. But again, this is kind of like the intro. This is what it looks like to write Rust kind of video. So we're kind of high leveling some stuff. I don't think the next section should be building our own errors necessarily. I think we call the next section maybe levels of error handling. I don't love the title, but right, because we're going to start with a couple of different like options, right? You can, inside of your own application, construct your own error types, right? Maybe we start with the application level. Right? If you're writing a main.rs and you just want to handle an error and you don't really care what that error is, the only thing you're going to do is going to print it. Then like anyhow result, use it everywhere, use the question mark everywhere, everything works out. Things become nice. So let me, right, like cargo add anyhow. And like the code example here is going to be something like this can return result, but it's going to return an anyhow result. Right? That's because we don't return okay down here. And then we got to do something that causes an error or potentially causes an error. So maybe we pull in like some IO. I think it's an FS actually. Let's do FS read to string. Right. Let file contents equals this. Right. And then we can do, this is going to be a string for line in file contents dot lines. Right. Which is a string slice. I guess we could put a buffer reader on this and get lines to be a result, but I don't know that that's super useful. I think the point of this is error handling, right? So line.parse I32. This is kind of silly example, right? But kind of drives the point home of you can just throw this in a loop. Let's call this total. Right, it's kind of very straightforward, very accessible in terms of like what this is doing. Get rid of the numbers array. We've got a total, we've got some stuff, and then we like print line total, right? So we've got error handling for the IO, we've got error handling for the parse. These are different errors that can all be handled with anyhow result, right? And anyhow has like these nice functions where we can be like numbers.text must exist and be a list of one number per line, right? Context comes in from that trait. Anyhow, context. Why is that not giving me a new line? That's so weird. Cargo plus nightly format. Nope. I guess we're just living with whatever I get here. Don't forget your curlies. Did I forget syntax? Did I miss something? Read to string numbers text, context, question mark, total, for in, curly braces, line parse. Print line. Good call. Not that that's our formatting issue, but right. And then we get numbers that text must exist and be a list of one number per line. We'll get this error in. I think I need to get rid of this other function that we're not using. Right. We'll kind of show, hey, this is the error output. If the file doesn't exist, like the context gets dumped. I'll just replace this with print line. Yeah. You know, sometimes it really do be like that. I want to take this into Rust Playground for a second and see if Rust Playground for some reason like formats this differently. Only slightly. I don't know why Rust Analyzer in VS Code is kind of having an issue. Maybe VS Code wants an update. I do have this issue where like VS Code like downloads another JS blob in the background or something, and then things break for no reason, which is really unfortunate, but might be what's happening. I might have just left VS Code open for too long. And then we can like add context here too, to be like, numbers must be I32s or something like that, right? So this fails if the file doesn't exist, which we've shown. And then if the file does exist, which is like 110, I don't know, 200, 4.2. Errors must be I32, error numbers must be I32s caused by invalid digit found in string. So this is like not the prettiest error output, right? But anyhow provides the basics to give the understanding that like there are ways, even if you just handle everything, to dump out context for a user to respond to. And I think that's the important note here. I think one of the things that I want to convey is that if you don't want to build up granular error types, you don't have to. Right? Is this building or did I... Here's our just expected comma. What happened there? Snap foo. Unclosed delimiter. Oh, I didn't put the string quotes around this error. This error, this link. And then that compiled. Cool. Everything's good. All is right in the typist world again. So levels of error handling, right? It is possible to be as granular as needed or as is useful. For example, so it's possible to be as granular as is useful when handling errors in Rust programs. For example, an application level error in a CLI tool might only care about reporting errors to users. For this, we can take advantage of one of many error reporting crates. In this case, we'll use anyhow. I think anyhow is a fine choice here. Link to latest docs is totally fine. Plop that in. For application level error reporting, we can take advantage of one of many error reporting crates. In this case, we'll use anyhow. Anyhow provides a new result type that can handle, what do we want to call it? Handle accepting any error, reporting any error. Nope, I just widened that so the sidebar wouldn't come out. Anyhow, error, a trait object-based error type for easy idiomatic error handling in Rust applications. That is a mouthful and not what I'm going to say. I think result is a type alias for result TE. So really it's providing the error type. Capture any error that you throw at it. That's not a bad idea, but what's your IDE theme? Night Owl? Exactly. You got it. It's Night Owl. It's also the theme that I use in my terminal and a bunch of other places. We didn't introduce Boxstein error, and I don't really want to. I don't really feel like Boxstein error is like beginner level content. And if you're using Boxstein error, you probably want to use something like anyhow or Miet or whatever anyway. Like, and none of this matters to somebody who's watching this video, right? Doesn't matter that error is a narrow pointer. Doesn't matter necessarily that the backtrace is available. It doesn't matter that it's send, sync, and static. Construct a new error object from any error type. And then there's the anyhow macro, right? That can handle impl error, yes. Impl from E from error. So anything that impls error can go into it, right? From E for error. Cold. I don't think I've ever seen cold before. Indicates this function is rarely called. When computing edge weights, cold. Generate code in a way that may be faster than it would do without the hint. This attribute are only hints and may be ignored. Indicates that a function is unlikely to be called. Interesting. I've never really seen cold used before. So what is standard error? Standard error is just an alias for error. So anything that implements error can effectively be mapped into. I don't think we really talked about why you can use the try operator with different error types. We kind of left it for option. So this isn't really... Anyhow provides a new anyhow error type and a type alias anyhow result that uses it as the default error type. It also implements from for any type that implements the standard library error trait, which means any error, any type that implements error can be returned using the try operator. We'll go with anyhow also. Implements. I like getting rid of it and this and that and things that are like indirectly point to things in this kind of content. It's better to be specific. Anyhow provides an anyhow error type and a type alias anyhow result that uses it as the default error, that uses anyhow error as the default error type. Anyhow also implements from for any type that implements... This is going to be a mouthful. How do I say this better? Anyhow also implements from for any error. That is an error in this case is any type that implements the standard library error trait. This means any type that implements error can be returned using the try operator if the function returns anyhow result. I think that's better. Splitting that into 3 lines. Let's get standard error link here. And put my hands on the right position in the keyboard. That would really help my typing. And then do we have a link to... Because error doesn't change, right? Not in anyhow anyway. Let's get rid of the end and just use a direct link to anyhow error. So anyhow provides a new error type and a type alias anyhow result that uses anyhow error as a default error type. Anyhow also implements from. We haven't really talked about from, so we should link it. The other place this PDF is going to go is just like in an email to people for whoever wants it. So having links to all these things is really important. And we're going to have to find some link styling for the PDF. There's no link styling in the PDF right now. Anyhow also implements from for any error. An error in this case is any type that implements the standard library error trait. This means any type that implements error can be returned using the try operator if the function returns anyhow result. And then we didn't put the code down yet, did we? So the code we have here is here. Example, which attempts to read a file using read to string. And attempts, well, I'll finish that sentence in a second. Consider the following example. A numbers.txt file. The program attempts to read a numbers.txt file. Returning the error, IO error, if the file doesn't exist. Program uses anyhow result as the return type. The program uses anyhow result as the return type, enabling the handling of many different error values. The first action that can fail is an attempt to read a numbers.txt file. If the file doesn't exist, or doesn't have the right permissions, a result, that's result containing an IO error, is returned. We take advantage of anyhow's ability to add additional context to errors when they happen. For returning the error using the try operator, before using the try operator to unwrap or return the error. So first action that can fail is an attempt to read a numbers.txt file. If the file doesn't exist or doesn't have the right permissions or something like that, a result containing an IO error is returned. This should be a link. We take advantage of anyhow's ability to add additional context to errors when they happen. Do I need to mention that this is, I think it's pretty obvious that this is coming from context. They're both named the same thing. I think that's something that somebody can infer from the code. Before using the try operator to unwrap or return the error. If the file doesn't exist, the application prints the error out along with the context we added. Let's get rid of some of these extra things. Whoop, just cut off after watching the beginning at 2.5x. 2.5x is pretty sweet. 2.5x is, I usually go to low twos is where I'm at right now. I haven't tried to push forward. I haven't listened to a lot of podcasts or anything recently, but 2x is 2.5x is fast. Don't want to derail, but where we are now, but Builder will be awesome. Builder is going to be awesome, I think. I don't exactly know how it works yet because I haven't used it. But I'm really hopeful that Builder is what everybody has been wanting forever, which is just like a global build directory built into Cargo, which should help cut down on a number of things, including potentially build time across projects. You too were wondering about Chris's theme. Really nice streaming setup. Yeah, I think that the options when I looked at how to make videos were basically either put a bunch of effort into taking the appropriate videos and screenshots in the right resolutions and then piecing them back together in a video, or taking the option of setting everything up like you would want to see it in a video, even though it's not perfect, and then relying on that for things like streaming and video creation. Because now I can just pop open a VS Code in a terminal and they're like on the screen in the way that you would want them to be on screen. And it's much more obvious how big the text needs to be when you're recording and things like that. Because like, it's actually on the monitor, right? So Yabai is super important for that. And then, yeah, really, it's just Yabai, if I'm being honest. Night Owl is solid. I like Night Owl. It's more of a personal preference than a stream preference, though. I use VS Code because it's more obvious to people when I'm clicking around. It's a little bit awkward when I'm doing things like this PDF, because this PDF is like super bright, right? I think this has a dark mode view. Use dark appearance. I don't know if this is better. I'm not a huge fan of reading white text on dark background like this. Like, it just feels a little bit harder. Like, you'll notice that like my code editor doesn't use white for the text and doesn't use like black or dark gray for the background. It's like a colored background and it's an off-white text. But this uses something that's much more close to like actually white and much closer to like actually black, which just doesn't feel that good to me. I feel like a lot of, this is a personal opinion, a lot of dark mode that people put on websites tends to be like, oh, we can go to the website. Let's see if I can find a quick website that has a only light mode. Let's search for a light mode website. Stack Overflow is only white, right? Yeah. So like one of the approaches that people tend to take when they do a dark mode is very much like filter invert, right? And now, oh my, you already have a dark mode. But like this dark mode sucks. Like if you're a dark mode user, I think inverting the page is not good enough, right? Inverting the page is like a very, very, very baseline support for a dark mode and really doesn't do it justice. But this is what I see a lot of places do. Had no idea filter invert was a thing today. I learned. Well, we're learning CSS today, apparently. That's what I get for spending multiple decades in web. Every time I look at your stream, you're reminded to get Yabai going again. Yabai is so good. And it's stable now that I've upgraded my Mac. I was having issues where I upgraded Yabai, but didn't upgrade to Tahoe. So I was like a major version behind on Mac or two. And I was having some issues, but I upgraded my computer finally, and everything's stable again. Editing has been the bane of your life. Definitely going to be doing something similar set up for new vids. Going to try Helix with a Shoki. Same theme I used already, but different editor. Nice. That's awesome. Yeah, I think that you can set all the spacing between the windows and everything with Yabai. You can do a whole bunch of interesting things. I don't do too many interesting things The one thing that I would suggest doing if you're going to use it for video creation is set window shadow off. Right. So I use window shadow off. I'm not even sure people recognize that, but this is window shadow on. And you can see how when I click through all of these windows, the view on screen changes. Right. And this is like really distracting in videos. So if you take it off, it looks like this. Which is significantly better for continuity purposes. Right. If I happen to have like the terminal in the top left selected and I'm talking about VS Code, it doesn't matter if I don't have window shadow on. I've been meaning to have a Yabai layout just for shorts, but I never got around to it. So my shorts kind of like overflow on the sides a little bit. Where were we? Error types. Just started learning Zalige. It's not as pretty. You can get rid of all the stuff in Zalige. Right? Like here's a bunch of regular stuff, like all the top tab and whatever. But if you, I forget how to do this. My problem with Zalige is I never remember exactly what the button that I want to click is. But you can do a decent amount with like deciding whether the bottom tabs are there or not and things like that. Let's see, pane, new. Like you don't need to show the alt on top, like that vertical setup or whatever. You don't need to show the tabs. You don't need to show the bottom. Those are all just Zalige plugins. So you can totally get rid of them if you want to. Like I said, I just get confused when I take them off. So I just choose to not use it on stream. What I really need is a way to like optionally show them, but I haven't done that myself. Sorry, you've been a big distraction. This has been very useful for me personally. Sorry to everyone else. That's fine. No, like the questions and stuff are good because there's definitely other people who there's a lot of people who lurk. And those people often have similar questions to the questions that people ask, but a lot of lurkers just like decide not to send messages or whatnot. So the questions are always on topic. Okay, so levels of error handling. It's possible to be as granular as is useful when handling errors in Rust programs. For example, an application level error in a CLI tool might only care about reporting errors to users. For application level error reporting, we can take advantage of one of many error reporting crates. In this case, we'll use anyhow, cargo add anyhow. Anyhow provides an error type and a type alias anyhow result that uses anyhow error as the default error type. Anyhow also implements from for any error. An error in this case is any type that implements the standard library error trait. And this is going to be pretty fast in a video. Like I'm going to show the error trait page. Also, chat doesn't do at least a little distraction. You aren't doing your job. This means that any type that implements error can be returned using the try operator if the function returns anyhow result. Consider the following example. The program uses anyhow result as the return type, enabling the handling of many different error values. I always kind of feel 50-50 on whether the code should come before that sentence or not. Right? Like I'm going to start talking about the code. Do I just throw the code at you with no context, or do I set up the context, show the code, and then do the rest of the explanation? I think that's what I land on most of the time. Small setup, code example, rest of the explanation. It's much easier to handle this in video form because it's not linear. I can show the whole code example and start talking about it at the same time. But in a written document, it's very like, the order is a little bit weird. The program uses anyhow result as a return type, enabling the handling of many different error values. If the first action that can fail, or the first action that can fail is an attempt to read a numbers.txt file. If the file doesn't exist or doesn't have the right permissions, a result containing an IO error is returned. I guess I want to kind of be clear that we're returning a result with the error variant. So let's specify specifically that it's a result error variant containing an IO error. We take advantage of anyhow's ability to add additional context to errors when they happen before using the try operator to unwrap or return the error. So that like explains the first, 3 lines, 2 lines of this. If the file doesn't exist, the application prints the error out along with the context that we added. Here's a demo of the actual error. Like this can be like left and right side of a video. It is assumed that the numbers.txt is a file like the following, containing I32 values. In this case, we have a float value, which will fail to parse. Since we're iterating over each line and attempting to parse it into an I32, the for loop, and attempting to parse it into an I32, we can again add context to the potential parse int error that will happen when we encounter the float. Doing application level error handling this way means that there's very little additional setup. We can also still add context to the errors as they happen. So we've covered application level error handling. By contrast, it's often the case in libraries. You want to be more specific about the errors that can be returned. For this, we can build our own error types at any granularity. An error type for the entire library crate is a fairly common approach. But you could do an error type for every function if you wanted to. If you were okay with the extra overhead of writing a bunch of different error types. So then we go into building our own errors. And we've kind of like, we've said, hey, if you have an application and it doesn't really matter, you're not really handling these errors, you can just print them out. You have context, you can add it to them. And then this gets dumped out, right? But if you're writing a library or you want to handle your errors more specifically, you can build your own error types. And then you can then like match on them and whatever. So similar to how we saw get disjoint mute error earlier, which we see earlier in this PDF. Similar to how we saw get disjoint mute error was an enum with multiple variants, we can construct our own error types. Typically, this is made easier by the crate ecosystem. Which can derive implementations of the error trait for you, of the standard library error trait for you. Specifically, I guess this is the same thing. Specifically, this error is extremely commonly used, an extremely common trait to use. Since it makes writing error variants easier. There are also additional options like snafu. This is this error demo on their page. So I think there's benefit to just using this error demo, because if we talk about it here, then we are explaining it. And when somebody goes to the actual this error documentation, they see the same thing and thus feel like they understand it a little bit. There's also benefit in constructing a from scratch error. But this particular point in the video is not dedicated to all of the details. We have a different chapter for doing all the details. So I think we're going to leave it with the same error definition that is in this error docs, because then we will be able to connect for people between what this is and like an explanation for what it does. So when they go to use it, they feel like they understand it a little bit better. Okay, that's cool. This is cool. We did cargo add. Maybe we won't talk about crate features. I don't know how important that is. Given a hypothetical data store library crate, a custom error type could look like this. This error provides a derive macro and a set of attributes to make defining errors easier. In this case, we see a variety of error message in this case, we see a variety of error message format strings that can optionally include data from the error variant itself. I think we talked about format strings already, so this should be fine. It is also the case that we'll have to interface with other errors, such as those from reading a file. For this, I don't want to say for this error. For this error provides a from attribute macro that, let's add this error to our project. Cargo add this error. And let's do a cargo run. Let's grab an error type down here. This is standard IO error, import IO. And really what I want is expand macro recursively, which isn't available. We have to do it on the derive. I'm not going to mention any of this code because this code is kind of like deep in the weeds. I wanted to look at this and make sure that what I was saying is accurate about it. So the from attribute will result in a from implementation to turn an IO error into a data store error. Results in a from implementation that connects the relevant error to our custom error type. In this case, that means we can use the IO error returned from operations like read to string that means we can use the try operator on an IO error returned from operations like read to string if our function returns custom error type. We wrap the whole IO error in a new variant of our custom error when this happens automatically. So I think it's worth pointing out that this is a thing, that this can work. I don't know that we need to write a function that uses it. Maybe, maybe not. We definitely can, right? Like it's not that hard to write something that returns this IO error, for example. It's a little weird to like throw our custom error in like this. Context goes away if we do this. Parseint error doesn't have a place. So we can just do debug file contents. And this can be some other function. Right? There's a syntax error there. I think it's because we don't have a main and a bind. Right, read data file. .unwrap, I don't know. Right, cargo run this, it compiles, runs, everything's fine. File contents, 110, whatever, it works. So now we can kind of include this as a little demo. I think that's enough. Control flow, pattern matching, generics and traits. What are we at? I'm looking at our counter here. I don't know why that keeps going to, we're at 7,000 words. Just tacking on more content. Oh. I know I'm just ripping through like Rust language features here, but if anybody in chat has specific questions about any specific kind of feature or whatever of Rust, feel free to ask as well. Okay, so the sections that we have left, which of them are important? Is control flow really important? Control flow is literally just going to be like more syntax. And I don't know that throwing more syntax at people is going to be useful in this video. I think that this deserves its own chapter later on. And to talk about pattern matching, we kind of have to talk about some of the control flow stuff. But talking about iterators is more important. So I'm going to pull this out, at least for now. I don't know if we're going to cover these in this video. I don't know. This video doesn't have to cover everything. And specifically, I don't think I have a high level point to make about control flow. Like I have high level points to make about, where's our outline? Right, yada, yada, yada. I wish I could set the theme of this dark mode, because this is too bright and the other way is too unreadable. I think I have overriding points to make about like cargo being important, Rust analyzer being important. Rust is an expression-based language. Data is owned by one variable, which is ownership. Data structures is very syntax heavy, but we kind of have to get through some of the customs, like some of the syntax to get to the point of owned data is easier to work with. Error handling, like the library versus like application level error handling, I think is really important. Mentioning option and result is like a difference from other languages. So talking about those is really important. Recoverable and unrecoverable errors. Generics and traits. I don't know that we need to go deep into generics and traits. Honestly, I think we can mention that Rust has them, that their like traits are useful. We've talked about a couple already. I think we have to talk about traits to talk about iterators. So I think we really talk about iterators here, and maybe tack on some generics and trait talk in combination with that. Documentation and testing are going to be very light, I think. I think right now we are effectively running out of time in the video. I want to keep the video under half an hour. talking about, Rust as an expression-based language and ownership, the data structures, the error handling, iterators. I think that's a solid intro. See, we have like a more concrete set of chapters here, right? Some in product types, ownership, where we talk about lifetimes then. I don't think we really need to talk about lifetimes. We talked about like how long values live for. Generics and traits, derive macros, derive more. Iterators and closures. We're not really probably going to talk all that much about closures and like the specific traits in this video. We will have to talk about that in the deep dive, but not in this particular like overview video. We did error handling. Control flow gets its own chapter. Pattern matching, context to control flow in that chapter. Testing, like unit integration, documentation, cargo next test, table-based testing, snapshot testing. I think all of that goes into its own chapter on testing. One of the things that I've learned from doing a bunch of workshops over the years is that people will just skip whatever they're not interested in. And I know that a lot of people who write code are not necessarily interested in writing tests and not necessarily interested in documenting things. I think it's important to mention that they are first-class citizens in a Rust world, right? You just get the ability to test random stuff. You just get the ability to document items. But doing long deep dives might phase people out of the video. And then in these chapters, we get into some interesting stuff as well. Some like tracing and structured logging, right? Serialization and deserialization. Probably not going to pull those up into this video because this video is already getting pretty long and this is like a basics intro level. Bunch of other things, bunch of patterns, right? New types versus type alias, builder patterns, deref, etc. There's a lot worth going into. And then we don't really have intermediate or advanced like planned out yet. We're just kind of kicking things that don't fit forward a little bit. And I think that's things like constant static. That's things like using threads. That's things like using async. So there's a lot going on here. And then there's also stuff afterwards, right? I guess in the intermediate advanced, we can talk about stack and heap for Rust stuff. Talk about a number of different traits that are probably useful, like from and try from, default, debug, display, eq, partial eq, ord, partial ord, stuff like that. Shared references versus index-based data structures, I think, is a pattern, but it's probably an intermediate to advanced pattern more than a beginner pattern. Rust Analyzer configuration. Rust Analyzer can get its own chapter in the Rust chapter. The orphan rule we didn't really talk about, but new type as a workaround for that. WASM probably going to be its own thing entirely. I actually already have some content for that. So we end up with like 3 videos currently, which are not 3 videos, sorry. We end up with like a why Rust, what is Rust kind of video. We end up with a dive into Rust, like less than 30-minute video. And we end up with this like series of kind of deep dives into each of these chapters, which will come with video and written content. So I'm not worried about leaving stuff out of this video because this video is meant to be less than 30 minutes and we'll have an opportunity to go deeper. Will there be a section taught not to ask an LLM about the seahorse emoji? I have no idea what that's a reference to. I'm going to be honest. Are you referring to the commit emojis that you didn't like the other day? And then we're getting into something that I'm kind of calling pipelines. One of the things that I've discovered from Rust Adventure is that all of this Rust language content fits on there. But once you start getting too deep into a domain, that kind of needs to get foisted onto a different domain. That's so weird. That's just so weird. I don't want to dive into that, but that is so weird. And these pipelines are currently on the Rust Adventure website themselves, right? They're on the primary domain, but I find that people who are looking for specific domains go to those specific domains. So like bevyadventure.dev instead of, or bevy.rustadventure.dev. I haven't decided if this is going to be like subdomains or not. I think full domains is probably better. It's not an infrastructure issue to do either one. So, and then we can put Leptos stuff there. We can put Bevy stuff here, you know, command line stuff, web backend stuff, API stuff, WASM stuff, embedded stuff, etc. Those all go on their own domains. So this is currently a 32-page document where almost all of it is this alleged 33-minute video that I'm going to do. Would you recommend Rust for developing systems rather than application tools? I would recommend Rust in general as a good tool. I think there are reasons to not choose Rust, right? And we could go over those, for example, in this video. It really depends on the application, depends on the skill set that you have on the team. I think one of Rust's weak points right now is non-web UI. You wrote your CV in Rust? I guess technically speaking, I'm writing this whole thing in Rust, right? Because I'm using Typist. My general sense is that Rust is a uniquely positioned language. So this is like getting into kind of the why Rust video, but Rust is a uniquely positioned language and it can take you to many places that you would want to go, right? So you can use Rust to do classic system stuff. You know, you can build a network stack in Rust. You can build a kernel in Rust. You can do, you know, tracing and logging infrastructure in Rust. You can build microservices in Rust. You can also do web backend, games, web front end with something like Leptos. You can put Rust as the backend in a Tory app and write like front end JavaScript backend native Rust. You can put Rust as shared libraries on Android and iOS. I would probably, if you're doing like an iOS UI application, use either React Native, which calls out to like Swift and stuff, or use Swift, right? I'm not convinced of multi-platform toolkits like Dioxys for mobile just yet. I'm curious to see where they'll go, but yeah. So like I said, there's reasons to not use Rust for various things. I think it would depend on the application, who's building it. Do you have any like skill set in the area? But I would say that Rust is great for systems, like systems programming and application tools. That's kind of the point that I really want to get across, right? Because if you look at this code, right? This code is read to string. Here's your string, deal with your string, right? But there's also, this is built on, can we just click on this? Maybe I don't have to write it. Yeah, so if we click on read to string, you can see that Rust has this idea of kind of like zero cost abstractions. And read to string here is you're choosing to read everything into memory at the same time and place it into a string. So it uses the file open API. It uses the metadata to figure out how big the file is. It creates a string that is that size, reserves that size, reads everything into the string, and then returns it, right? So you don't have to write all of this, but it's there for you if you want to. On that topic, if, for example, we were going to do, let me write this up in main. If we were going to do like file open, numbers.txt, this is going to be, we have anyhow, so let's just do anyhow result, right? And this is an okay. And this is, I don't know, a file. It doesn't matter what this variable name is. Why is that returning as unit or never? Standard file. Let's say that I'm going to read from this file. I don't want to read the whole thing into string because it's like super big file, something that can't fit into memory. Maybe I have small memory, maybe on a microcontroller, maybe I just want to use memory efficiently. So we can do buff reader. Well, let's we had the code here before, but in the demo down here, it's like file contents dot lines, right? And it's like 4 line in lines, like debug line. This reads the entire string into memory, iterates over the string via lines. Maybe you're doing the 1 billion rows challenge. That's funny. But maybe you don't want to read them all at the same time, right? So this is like, I forget if this is new, right? Buff reader, new file. So let reader equal buff reader, right? So the same stuff that this file read to string is built on is like the read trait, etc. Buff reader requires that you implement the read trait. File implements the read trait. Now we have a reader. With basically the same code. We're going to pull the trait into scope. Basically the same code here, but you'll see that here we have the string slice, right? Because we read everything into a string. We have everything in memory and we're iterating over it while it's all in memory. But up here, what we're doing, let's just write the code the same way. What we're doing is we have now wrapped our file into a buff reader, which has an internal buffer, which will do buffered reading to this file. So now you've got a significantly more efficient file read, but you're still operating on each line, right? You now have to deal with the error if the line fails to parse, right? Because you didn't read the whole thing in to start with. But Rust is really good at this kind of thing, where you have the high-level API. It's built on a set of traits and functionality. You're choosing to read everything into memory here, but you can also choose to do lower level stuff. You can go even lower level than this and manage it yourself if you want to, et cetera, et cetera. So this is what I mean when I say like it's good for systems programming and it's good for application programming. I don't view ownership as a memory management tool. I know a lot of people are like, oh, Rust, ownership, memory management, et cetera. I don't view ownership as a memory management tool. I use ownership as a way to guarantee that I'm not modifying the same thing from 2 different locations and I'm not getting like spooky action at a distance. Like the Rust compiler prevents me from having some random piece of code modifying the thing that I'm actively working on, which is just really nice, right? And that's not really a memory safety kind of thing. But there are benefits to it as well for low level. Theos Quest says, agreed, non-web is still early days. You've been using Dioxis, including for non-web UI, but it's absolutely not ready for a professional level app at the moment. Will be awesome when it is, though. Yeah, I very honestly haven't dug too deep into Dioxis recently. I did for a couple of the earlier versions, but I was not really able to get a workflow that I was happy with. So I kind of left it alone for a little while. I'll go back to it and check it out again at some point. I think Blitz is really cool. I think the stuff they're doing with hot reloading is really cool. I think they're pushing a lot of really interesting work forward for the ecosystem. The hot reloading stuff they were working on has benefits for both Bevy and Leptos, for example. And it's important to like give credit to the Dioxis team for that because they really pushed that research project forward and now everybody can benefit from it. But yeah. Really long-winded answer, I think. But that is to say, I do really think that Rust is both, it's like uniquely positioned to be low level and high level. You can embed it in, Python or JavaScript and expose Python or JavaScript APIs to Python or JavaScript users. They don't even need to know that it's Rust under the hood, but they can get all the performance benefits of, this systems level thing that you decided to use, which is really cool. I think one of the powers of Rust is that it works really well with other things. It's not like Rust or nothing. It's like you can write everything in Rust if you want to, but you can also FFI to a whole bunch of stuff, and you can also use Rust to provide FFI, right? Like you can use Rust to provide functions to these other systems like Python and JavaScript, etc. Which are going to be probably their own workshops, their own pipelines, right? There's some cool stuff for like an API. This is one of the most popular ways to do Rust targeted at JavaScript users. And then there's what? It's not Pio3. What is it Pio3? Pio3. Same thing, but for Python. Doesn't have a fancy website, but it's still pretty cool. Sometimes I think about putting Rust into the Skein package for Blender. Because theoretically, if I do that, then I can just use some Bevy crates, which would be really cool. Python over C has been incredibly powerful. Natural expansion was Python over Rust. Chatting with a few friends in ML. A lot of them are finding that Rust accessibility over C means they're dropping the Python layer and going whole Rust. Hit that YouTube comment limit, did you? Yeah, I think that it's really interesting in the sense that like Rust feels like a JavaScript, right? Like Rust feels, and I don't mean it in the way that like there's a bunch of people who are like, oh, I don't like JavaScript for XYZ reasons, right? I mean, Rust is like a JavaScript in the sense that it can be a language that you pick up and just start using, right? I think that most of the problems people have when learning Rust come from preconceived notions about how languages are supposed to work, right? Other languages like C will just let you do whatever you want with a pointer. So if you've spent, 10 years, 20 years trying to figure out how to manually manage pointers such that you don't get, null pointer errors and stuff, then if Rust takes that away, you kind of feel like you're losing a little bit of that freedom. But I think going from the other direction, going from something like JavaScript or Ruby or Python to Rust is like you have this language that feels a lot like one of those languages, a lot like a memory managed language, but it's actually not memory managed. And the ownership model actually doesn't really get in your way all that much. I know that people tend to have trouble with it, and I'm not discounting that, but I think Rust is a very productive language, is the way that I'll frame it. So, we have plenty of time, and we have to get through, I think iterators, from all that conversation, iterators is the next big thing. I don't think we actually need to be like, oh, generics. I think we need to talk about iterators. We need to talk about the fact that testing and documentation are built in. I don't think we necessarily need to cover, I guess, how to read documentation. I kind of want to throw in how to read documentation at the end, but it'll be Maybe for standard library stuff. I don't know. I think I'm going to leave control flow out. I think I'm going to leave pattern matching out. We don't need to cover all the syntax, and these are going to be very syntax heavy. So generics and traits, and this is actually going to be iterators, right? So the framing here then is quote, Rust is hard, end quote, is so silly. Programming is hard, but we all learned it. Rust is no harder than other languages. There's quirks in all languages. You've taught folks straight out of boot camps with no issues. Yes. Yeah. I think actually the less preconceived notions you have, or the fewer preconceived notions you have, the easier Rust is for you. I think that it's no harder than learning any other programming language if you put them like, here's your first programming language. I think if you are a person who has written certain kinds of languages that are very close to each other, it can be very easy to feel like all languages are the same. But that is very, very not true. And getting outside of that bubble and, you know, looking at languages like Erlang and Prolog and Haskell and Lisp and IO and et cetera, is just so useful if you are a person who is going to like have a multi-decade programming career. Unlearn the bad habits is hard. Yeah, unlearning any habits is hard. They don't necessarily have to be bad. Okay, so iterators. What are we going to say about iterators? I think that for somebody who doesn't know anything about traits, doesn't know anything about generics, doesn't know anything about et cetera, what is the important thing to say about iterators? And I think it is that iterators power how you iterate over everything, right? Like the for loop is just syntax sugar for an iterator, right? So we will have something here. Let numbers equals vec. Maybe we don't make this sorted. How do I want to introduce iterators? I think we don't need to do all that many examples here. It's funny that it wanted to replace this with while let. Like iterator is a trait, into iterator is important. I think those details can fit in the dedicated chapter. Iterator is just a trait that provides a next function. Composable external iteration. We're not going to say that. Wow. Could you imagine how people would just like glaze over if I said that in a video? They don't really talk about the why here at all. They just say iterators are how this happens. An iterator has a next method, yada yada. implementing iterator, for loops and into iterator, iterating by reference, adapters. I think iterators are lazy is probably important. Let's just say that this is the way to do iteration. I know that that's not the best word to use, but when looping over a collection's items like a vec of I32s, iterators are the idiomatic approach. Iterator, we don't talk about traits. Not all that much. I don't really think we have to, if I'm being perfectly honest. Like, yes, traits, but if you're actually going to go write your own traits, then you probably are going to go read the chapter on traits. So iterator is a trait. Man, this is really going to dump a bunch of stuff on them at once, and I don't want to do that. What I'm thinking here is that iterator is basically something you can implement for a struct, and that struct controls how the iteration happens. But none of that matters to somebody who's just trying to figure out how to use iterators. When looping over collections items like a vec of I32s, iterators are the idiomatic approach. Even a for loop is syntactic sugar for an iterator. I don't want to say that there's many possible implementations. I want to say, because like you would really just implement iterator because of the associated type. You can only implement iterator once. Many possible structs that can implement iterator. And then maybe we talk about some of the functions, right? I don't want to get too deep. It's really, really easy to get deep into like, here are the little things that make up an iterator, right? An iterator, has an associated type called item. That item is used when you iterate over things, yada, yada, yada. None terminates an iterator. I don't know that any of that is really like high level important. I think like talking about iterator adapters and stuff is probably not important. For example, let's go for vec. Let's just call out a couple of the different things that can produce an iterator. So extract if is one. Iter would probably be another. I think 2 is fine, actually. Windows, we don't have windows on, we have windows on slice, right? Chunks and windows on slice. Nope, array windows is nightly only still. That'll be my favorite Rust release. Iterator is a monad. You should definitely explain that. So today we're going to talk about burritos and how an iterator is really the beans of your burrito. Returns an iterator with chunk size elements. I think chunks might be an interesting one. I just want to pick a couple of interesting ones. I don't really want to like list out a whole bunch of them. Windows is another one. Extract if is interesting. Chunks are windows, yeah. Back. Back and slice have a number of functions that can return iterators. This includes, but is not limited to, iter. We'll go with Windows. Extract if, and more. Iter is fairly common on collections that can be iterated over. It returns an iterator of the items in the collection as expected. As expected is the wrong way to phrase that. It returns an iterator of the item. It returns an iterator over the items in the collection one by one. And then we have like a short example of like 10, 20, 30, 40, 50, 60, right? For numbers dot iter. I guess we can use for loops here. Right? Because then this is just a really basic program that prints out a bunch of numbers. It returns an iterator over the items on the collection one by one. I don't think we need to really talk about like shared reference and like taking ownership, like iter and into iter. I'm going to leave it to one iter function of those two. I'm going to talk about the one iterator trait, not the into iterator trait, and then Windows and extract if as variations. Windows is slightly more interesting. The stream is dead on your side. Can refresh? Testing. Hey, Bob. Thanks. Okay, so the output prints each number in turn. Windows is slightly more interesting. Iterates over each pair of items. Right, we got to pass in a number here as a slice. I think just dumping a couple of these examples is good to get a vibe for like what is actually going on here. Because theoretically, somebody will have not seen any of these, right? Somebody watching the video anyway. And again, we're going to go deep dive at a different time. It iterates over each, I don't want to say combination. Continuous. It iterates over a slice of arbitrary length. Starting from each item. I think that's an okay way to phrase it. It's a kind of a one-off comment. So like if somebody really doesn't understand what's going on here, it's not super important that they do. Just like there is another function that returns, you know, a different kind of iterator, an iterator with different, you know, item types. We chose a window size of 2. And then we've got extractive. Extractive is interesting. Extract if takes a range, which we'll do for everything, and takes a test, I believe. So this is a closure, right? Is multiple of 2. Get my parentheses right here. Item over 10. Why is that an issue? Because it's a reference. Is multiple of on ambiguous number type. Let's define the type here. Is that not gonna... I haven't used is multiple of that often. It's only been since like last, a very recent Rust release. You can't do is multiple of for I32. I guess we'll do U32. Isn't that weird? Right, it needs to be mutable because it's extract if. This is not going to be a 4. Right? Well, I guess this can be a for loop, right? Because this will print out, and then at the end, we'll debug numbers. And we end up printing out all the even ones and leaving all the odd ones. A rolling window. A rolling window is a good framing for that. I see your stream's back. Rolling window as a slice. It iterates over each of the numbers. Windows is slightly more interesting. The items provided in each iteration are a rolling window. Viewed as a slice of arbitrary length. We used view earlier on to talk about slices, so view shouldn't be that uncommon. The items provided in each iteration are a rolling window. Viewed as a slice of arbitrary length. I think that's fine. It doesn't matter all that much. This is going to be a one-off sentence. And the point is that we can get multiple kinds of output here for the items. But yeah. So extract if is interesting, right? Because extract if is... Do I pull this out? I think I might. This might cause issues. No, we're good. It might be like weird for people to see this get stored in a variable and then used, but I think that that is fine. That sets us up very quickly. A more exotic iterator is, I guess, a more interesting iterator is provided by extract if. Which accepts a range to operate on. And a closure to test the value. Test the items. If the item passes the test, it is removed from the original vec. This leaves all the test failure, all the items that failed the test, all the items that failed the test in the original vec, and all the items that pass the test become available in the iterator. Does that make sense? More interesting iterator is provided by extract if, which accepts a range to operate on. And if somebody's coming from C++, maybe they'll link with the idea of string view or ranges view. Yeah, if you call it weird. Yeah. I see your comment that says that is weird. I assume I said something was weird. but I don't remember what it was. If it was important, let me know. Yeah, using the term view when talking about iterators. I think, well, view in specifically view when talking about slices is what that is, right? Viewed as a slice of arbitrary length, because the thing that you get here is a slice of the items in the vec. And slices are views into the vec. More interesting iterators provided by Extractive. Extractive, by the way, one of my favorite iterators. It's just like if I had to pick a favorite iterator producer, Extractive is probably at the top of my list. It's probably number one for me. A more interesting iterator is provided by Extractive, which accepts a range to operate on and a closure to test the items. If the item passes the test, it is removed from the original vec. This leaves all the items that failed the test in the original vec, and all the items that passed the test become available in the iterator. This produces a log for each item before logging the entire original vec, which has now been mutated. Okay, I don't know that we need to talk about this all that much. I do want to talk about, I think, map, something like that. This gets into like iterator adapters. How much should we talk about collect? Quick start. Source main. Let's see how much we talked about collect. I don't think we collected all that much. We basically have not talked about collect at all. So this is going to be the first instance of talking about collect, which I think is pretty important. Collect is a pretty powerful function. Once you have an iterator, you can use any of the functions on the iterator trait to continue to operate on the values, on the items, we'll call them. This includes functions like map, which can transform one type of value into another. Is there something more interesting than map that we should use? I don't really think so. I think in the deep dive, we obviously cover things like all and any. Cycles are super interesting. Enumerate is super interesting. Filter map, find map, flat map get their own section. People get scared by fold, but we'll mention it in the deep dive chapter. Min by, max by, sum, product, those are really interesting. Scan, I feel like I always have a use for and then I don't. Like, finally, I'll use scan for this, and then it's like not the right thing to use. Collecting into, or peekable is super interesting as well, right? Like, peekable, position, nth, all very interesting functions. I don't think that I want to cover really that many more. We might be able to mention them. I think map is a good example. So let's, I don't want to do a filter map, but at the risk of writing filter map instead of filter map, I think I'm going to do it. Right. Nenders.iter.filter item dot is multiple of 2. Let's use the same logic we just did. Item over 10. Why does that look weird? Got extra parens for sure. You have 4 instances of scan in your AOC 2024 repo. Interesting. You know, I feel like that's when it comes up the most for me. It's like, oh, I could use scan on this problem. And then it feels like it's never the solution that I want it to be. I always end up picking a different solution. I don't know. Things like this happening are interesting, right? Unused map that must be used because of the must use attribute macro. Like this is one of the things that makes Rust particularly interesting because the compiler can catch if you're not using something. Maybe we do that. I think we do that. This is the first example of code that really doesn't do what you expect it to do, I think. Like code that I actually don't think we talk about generics at all, thinking about it. I don't think we talk about generics. I don't think we mention traits all that much. I think we just say iterator is a trait. I think we leave that to the deep dive chapter, actually. I think we do iterators. We say iterator is a trait. It has these possible, functions on it and whatnot. But I don't think that we need to do a full treatment of trait in this video. We will do a full treatment of trait in the chapter deep dive, but not in this video. Find map might be nice to look at. Well, so we've got what? We've got iter, windows, and extract diff. So what does find map add to that? I guess it produces one value, right? In contrast to these others that iterate over a bunch of stuff. Maybe that's useful. Can also be used. Iterators can also return a single value, such as when using sum to sum all the items, or a function like find map. I don't know that we need find map particularly. Because what are we mapping it into? I guess it's good if you're doing this parse. This is actually a really good example. Do we just steal this example from the docs? This is actually like an entirely reasonable example. I think we're going to change the values here, but okay, let me comment this out. I think find map is a good call. LOL NAN 25. We're going to have this end with one that isn't a number. How do you spell 43? Let's go 25. Right, this won't parse as a number. Maybe I don't say that. Maybe I say tree. This just finds the first number. Guess that means that we would want tree first for this use case. Cannot satisfy underscore as from string error. Consider giving first number an explicit type. Right, because we're doing a parse here, and I want to parse these as I32s. This can be very useful when dealing with operations that can fail, like parse. Really just wants to break this onto a new line. I don't know that I love that style, but it's okay. Iterators can also return a single value, such as when using sum to sum up all the items, all to check that all the items pass a test, or a function like find map, which will find an item that passes a test and transform it into a different type. I want to say transform. I don't want to say map because we just used map here. This can be very useful when dealing with operations that can fail, like parse. Or that finds the first parsable number in a vec of string slice. Okay, it's quick enough. First number equals sum 2. It might be a little confusing that this is an option. And this returns an option because it could not find one. But I think we'll just leave that open. We'll talk about that more in the actual deep dive chapter. Blah, 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 blah. Filter map. Let's get rid of these up here and put them down here. Once you have an iterator, you can use any of the functions on the iterator trait to continue to operate on the items. This includes functions like map, which can transform one type of value into another, or functions like filter, which can filter items out. Note, however, that iterators in Rust are lazy and do nothing if they aren't called. You can call it manually or use a consuming iterator function like collect. We can call it manually, such as with a for loop, because we just introduced those before, or use a consuming iterator function like collect. One nice piece of Rust is that if you construct an iterator and don't use it, and don't call it, the compiler will warn you. This program produced that warning. I'm generally against negative examples, but it's hard to not use a negative example if you're going to talk about error messages. I think that if we go into too many other iterators, this starts to get a little bit too syntax heavy. Remember, the phase of the video that we're in right now, this is going to be ideally squished into less than 30 minutes. And then when people want to do a deep dive into iterators and traits and generics, there's going to be a dedicated chapter to that. And that is going to be its own 20-minute video or 30-minute video or whatever it is. So we'll get, like, iterators will get the full treatment. We'll talk about a whole bunch of different functions. We'll talk about zipping and unzipping or fold and things like that that people might not be aware of. We'll talk about being able to iter and iter mute. We'll talk about the difference between iter and into iter with references and ownership. We'll talk about how when an iterator returns none, that means it's done, how you can call next and it provides the other functions. It's a whole bunch of things, right, that are worth talking about. Including, like, iterator leads into talking about associated types versus generics, which is an interesting topic. But all of that goes into, like, the individuals more than anything else, like the individual chapters. So for as long as this video is, which is starting to get pretty big, let's see, CD, WC, we're at 7,500 words in this document right now. For as long as this video is, it is still not covering everything in depth, right? There's still going to be like a full chapter for each topic, which is wild. That's a wild amount of content. It's also wild that I wrote 7,500 words in like a week. This is in addition to everything else that I'm doing. So this is not the only writing I'm doing either. One nice piece of us is if you construct an area and don't call it, the compiler will warn you. This program will produce that warning. And show that the original vec was not modified. This doesn't need mute on it. It's kind of weird that I still had it there. But yeah, there's so much to talk about, and we can go into so much depth. I really want this to be like a video that introduces you to a bunch of concepts, but by definition, this video cannot cover everything, right? There has to be things that get dropped. Where was I? The warning. Right? Unused map that must be used. Map in this case is the map for filter map. Iterators are lazy and do nothing unless consumed. So we now have to show the actual result. This is U32, right? Oh, strings. This is a vec of strings. Which outputs this. I do feel a little bit that collect is so powerful that we should talk about the different ways in which you can collect. Like, if you collect a vec of parses, right, that can be a vec of results. If you want to stop at the first parse that fails, you can make that a result of vec and error. Hey, Elijah, how's it going? Good to see you. We're talking about iterators at the moment. Hopefully just finishing up the iterators section. Because this is a 35-page document. I think especially for really long stuff like this, I'm considering this really long, even though it's not really in comparison to all like the full content. I think audio visual is really useful for things that are this long, right? The ability to not have to manually go through everything and to have it kind of shown and paced is very useful. Okay. He's collecting the appropriate size. I want to mention things like, you know, if you have an iterator of tuples that you can collect it into a tuple of 2 vecs, things like that. I don't know that that really matters here. Will people really get it if I throw an example like that in? Right. Because we would have to write this example. I don't know. This is not going to be a vec of U32s anymore. This is going to be a vec, and it would be like A10, B20, C30, And then we can do collect into a vec of, or rather collect into a tuple of a vec of car and a vec of I-32, right? It's all typed out correctly. And then this is nothing, but all we're doing is iter and collecting. For some reason, that's not the right type signature. Where we go. Value of type, shared reference to car, I-32, shared reference to the tuple. Like this would be easy in general, I think, to just do cloned. We could also do into iter, dot collect, and then we just get both of them split. It doesn't need to be into iter, right? Like it makes sense for it to be into iter, but it doesn't need to be into iter. The implementation, because we don't talk about from iterator. The implementation is way down here. There's a bunch of cool implementations that you can find in here if you look. Where's the tuples one? I think it's this one. Impl A EA for a tuple of EAs and a tuple from iterator EA, so of some type, for a type where it's default and extend. Is that the right one? Yeah, cloned is fine too. Yeah. A tuple of types which implement default and extend. I guess theoretically, if they have to match up. So why is default required, actually? Ah, yes, spec tuple impl. Great. Hope we get variadics at some point. Allows to extend a tuple of collections that also implement extend. So the documentation is... Why is default necessary, though? Because theoretically, if you're passing in a tuple of values, those need to be... Those need to exist, right? I don't know. I might look at that off stream. I don't really know why default is required here. Tuple extend. Like, when would you use the default? It doesn't... It's hard to read the macro to figure it out, but... Iter, fold, extend. So it iterates, folds, and just calls extend, I guess. And extend... Extend doesn't require default or anything. Into iterator, item A. Extend one, some item. I don't know. I don't know why default, I can't find the reason default is included here. Does anybody know offhand? Right? Why does A have to implement default? Because theoretically, you're only providing values, right? There is no default call here. I mean, I'm sure there is a default call somewhere that I'm missing, but this is like default function name. Default function extend, default let res equal type : default. So it calls default. Oh, it calls default to initialize like the vec, which then doesn't have any items in it, and then extends with the rest of the iterator. Is that accurate? Is that what's happening here? Sorry, I'm getting distracted. Is it because the container vec does? I think it's because the initialization here relies on default to initialize that vec. And then extends it with the contents of the iterator. But to initialize this with default, then those items also have to implement default, even though there are no items in the original vec. I think that's what's going on here, which feels a little weird, honestly. So yeah, it does come down to the fact that effectively, like, the containing items have to implement it, which is strange. I think from the usage, other than looking at the internals, it feels like it shouldn't have default, but internally it uses default to initialize that final vec. Because presumably you don't need this to be a vec. Presumably you need this to be an arbitrary container, right? Which is just interesting. Sorry, I'm letting myself get distracted here. But like theoretically, this should work with that knowledge. So this doesn't need to be a vec, because if we have a tuple that is going to be a series of, let's say, cars, it can be a string, right? And we use default to initialize any type that would be there, which is just interesting. I find that super interesting. But I don't think I'm going to mention it up here. I think we're still talking basics up here. This is like vaguely advanced. We can definitely talk about it when we talk about iterators. I think it's important to call out Rayon. It's more important to call out Rayon than I think to call out Did you mention take for taking parts of the iterator? No, I didn't. Did not mention take. Didn't mention skip or nth or anything like that either. Again, this is not like the iterator deep dive. It is the iterator overview. So giving a couple of examples and kind of leaving the rest as an exercise to the reader is fine, because later we are going to actually write an iterator chapter. And when we write an iterator chapter, we can go deeper on what an iterator is. We can go deeper on collect. We can go deeper on traits like from iterator and into iterator. Double-ended iterator, things like that are also going to get mentioned in that chapter, right? All things iterator go into that chapter. Iterator overview goes here. Link Rayon provides data parallelism on iterators. So let's do 10, 20, 30, 40. I guess we could start generating this, right? I can't think of an operation that we could do here that would be interesting enough, but also simple enough and also matter. Hey, Zeno, how's it going? Hope you're doing well too. Numbers.iter. What do we have in the previous one? Let's just reuse the previous one, right? I think it would be really interesting if the only thing that we had to do here was par iter. Rayon has a prelude, right? Rayon prelude, perfect. Standard iter repeat 42. Very, very, very in parallel processing the number 42 many times. This I think is really interesting. This is just like so incredibly cool that you can go from iter to par iter, right? There's iter, there's par iter. Suddenly it's in parallel. That doesn't help us for these small amounts of values, which is fine. But Rayon and iter tools are great in general. Yeah, iter tools to me feels like a testing ground for upstreamed iterators, and I love that it exists. I don't think that we are going to talk much about any of this, right? If you already have an iterator, technically there's a function in here to like turn that into a parallel iterator, but we really don't need to. Right. Rayon guarantees data race free executions and takes advantage of parallelism when sensible based on workload at runtime. So I think this is really important to just be like, hey, you want parallel iterators? Here's a parallel iterator. Done. Okay. We are at 10:30. Perfect. So now we have documentation testing. Much later on, you can go over extending functionality of iterators like how Rayon does it maybe. Yes. Extension traits, you mean? Absolutely. I'm assuming that you know what an extension trait is, and that's why you're mentioning it. But if you don't, let me know, and I'll explain it. I guess for other people, like iter tools, for example, is an extension trait. You import the Iterators trait. Everything that implements iterate or that wants to implement Iterators has to implement iterator. There's an implementation that is suitably generic, right? Impl Iterators for T, where T implements iterator. So everything that implements iterator implements Iterators. Thus, if you bring this trait into scope, you get all of these functions on anything that implements iterator. Yeah, I was like, that's such a direct question that you obviously have to know. But for anybody else, that's what this is doing. It says, here's a trait. To implement this trait, you also have to implement iterator. And then it provides a extremely generic, we'll call them blanket implementations, where you implement Iterators for any type, where that type implements iterator. And then anything that is an iterator suddenly also has access to Iterators, which is very, 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 very cool. Extension traits have to make it into that chapter. Okay, so we are on documentation and testing, and then I think this whole thing, not the whole thing, this whole 30-minute video has effectively hit its cap, and it's time to go back and kind of just edit. And if I can edit all of that, it's fine. It's just a light 8,000 word video. It's just a light 8,000 word video. Okay. Obviously, you just speed up the video to fit within the time frame of the content you made up. I feel like that would be... That's like adjusting the white space in an essay that you pass in college or something, or like in high school, where it's just like, this needs to be this many lines or like this many pages. And you're like, if I just increase the spacing to 1.2, maybe they won't notice. If I just sit in DaVinci and accelerate to like 1.2, maybe nobody will notice. And then I get an extra, what, 2 minutes? Oh, that's funny. Okay. You used some drone scanning app for free that had a video length limit. You definitely didn't upload a 4x speed 120 FPS video. That's really funny. I think it's even funnier if you're like if you were shooting in 30 FPS. That's even funnier if you lined it up like that. Oh man. Okay, so documentation comes with documentation tools built in. Tests need to go in the next section. Maybe we do testing before documentation. Every time you mention iterator, video speeds up by 2%. What is this, the B movie? Testing. The Rust tool chain we installed via Rust Up came with the necessary tools to run tests. Cargo includes a subcommand for running tests. defining tests. What do we talk about? Unit and integration tests, and that's about it. And then we close shop. I guess maybe we mention Insta as a side mention. RS test. I don't know. Do we mention more things? I think I mentioned them generically, like snapshot testing and table-based testing. Ecosystem, including snapshot testing and table-based testing and property-based testing. Snapshot testing, table-based testing, and property-based testing. And async testing. And tracing testing. Including snapshot testing, table-based testing, property-based testing, and more, is what we'll say. You're not familiar with what snapshot and table-based testing are. Maybe you've done those patterns without knowing the terms. So a snapshot test is... I actually have a video on my channel about Insta. Not Instagram. Insta. Insta, I think, has its own website. But basically the idea here is that you have some piece of code that generates some output, right? Maybe it's generating JSON, maybe it's generating a CSV, maybe it's generating a data structure of some kind. You have a function that returns something. And for whatever reason, it's not really all that beneficial to like test the internals of it. Maybe you just have like a crap ton of them. For example, one of the things that I do with Skeen, because it's so kind of awkward to deal with so many of the different component types and stuff, this is a directory of snapshot tests. So if I click into one of these, it's going to show me, here's some metadata, and here's the snapshot output. This happens to be for an anchor component. So I've written a test that basically says snapshot this. It outputs this value for whatever reason in the test that I have. And when I upgrade Bevy versions, I can run my snapshot tests and see if any of these changed. That's really what they're for. So you have this test, you use assert debug snapshot or whatever. It saves out the file the first time you run it. And for future runs, it will compare against that file. So you know if you broke the output or not without having to write a bunch of individual little tests for little pieces of functionality, right? Instead of writing, you know, field.a equals 2 and field.3 equals Chris and field.4 equals dog for, you know, 500 snapshot tests, you can just say for all these structs, snapshot them, save all those files, and then the next time you run the tests, if any of those snapshots change, the test will let you know. And you know if you broke the output. That's what a snapshot test is. A table-based test. Skiing like a portion of yarn? Yes, actually. That is one of the reasons that I called it that. Not RS test. Let's go with test case, because that's another one that I saw recently in a PR. So test case, or table-based test, is basically you have a bunch of values and you have a bunch of outputs. So like this is the input, this is the output, this is the message, right? All of them run through the same test. So it has an input that's an I8, an output that's an I8. Or, oh, sorry. In this case, it has two inputs, -2 and -4, and assumes that they pass. This is not the way that I usually write them. RS test, Rust. This is the way that I kind of usually write them. But basically the idea is you have some input, you have a bunch of the inputs. Basically you don't want to write this test for every case. Maybe you, in this case, there's 5 of them. In the other case, there were 3, but it's often that you have basically like a bunch of different test cases that you want to test for the same functionality. So this is testing multiplication, it looks like. And then it tests the output. So yeah. Interesting, that makes sense. You definitely a lot of time over the years testing equality in those kinds of ways. Yes. Yeah. It's kind of one of those things you can fall into. It's also known as golden tests, snapshot tests. Or what was said? I've heard them referred to as other names too. Like I think I heard somebody refer to it as like a red-blue test or something at one point, which was kind of weird. Cargo mutants is also helpful for finding areas in your test where bugs can be introduced without the test actually failing. Cargo mutants. A mutation testing tool for Rust. Maybe we mentioned mutation testing. Finding places where bugs... So this is fuzz testing, is what you're saying. I don't know if there's a difference between mutation testing and fuzz testing. But like, this is kind of like property-based testing as well. Right? Like property-based testing, there's just so many different ways to try to test, right? Oh, Luca, nice. Quick check and prop test. Quick check is a Haskell library. That's where probably a bunch of people were introduced to the concept. But the idea here is that you can define a property, right? Like this thing is commutative, or this thing is associative, or this thing does this. And then write a test that tries to prove that wrong effectively, right? Basically say, this should hold, try to find something that fails that category of stuff. And usually these things have, they aren't just running randomly. Usually they prioritize things that cause those issues up front. For example, if you were doing like a U32 or something, likely values to test would probably be like 0, 1, U32 max, you know, like weird values. But the idea is generally like, I think this property holds about my code. I'm going to write a test to try to prove that that property holds. Cool. So yeah, there's a whole bunch of like testing. Supported by the crates.io ecosystems, including snapshot testing, table-based testing, property-based testing, mutation testing, fuzz testing, and more. So this, let's start with this. Right, cargo new lib. What are we going to call this? We're going to call this testing ground, I guess. Cargo new lib testing ground. I should use the underscore, shouldn't I? Right. And then we run cargo test and the test pass. And cat source lib, carg source lib, cat source lib. And Rust provides source support for authoring tests through the test macro. I think that's enough. Through the test macro. If you initialize a new library crate with cargo new, it will come with unit tests. The lib.rs includes a function called add as tested in a module that only compiles running tests. The main difference between fuzzing and mutation testing is mutation makes small changes to the actual source code to see if the test holds, rather than how fuzzing introduces noise to the data. Okay, yeah, that makes sense. That's why there was that little warning on the cargo mutants. You have a Python code base right now with tons of fixtures grabbed from production to use as mocks for testing. Feels similar in a way. Yeah, in some sense it's similar. I think that in the case of grabbing mocks, right? What you're effectively doing is trying to snapshot the state of production and encode it in tests, which I actually don't really agree with as an idea, right? I think if you're going to try to test against production, you should have tests that run against production. If you are going to test and you feel like you need to mock the output of production, you should have a way to test your thing and the way that it integrates with another piece of code. I think that mocks are really a failure of infrastructure in that way. I know people find them useful. I don't really harp against them or anything, but I think that the inclusion of mocks in a code base are an infrastructure failure. You're not usually as diligent in testing as you should be, but sometimes when you write something like a parser, you go into test-driven development because you know more things that'll go wrong than right. Yeah, that's fair. Oh, you're completely right, but you're an engineer at a large enterprise company and shit's real jank. Yeah, totally. Right? Like, that's why I don't campaign against mocks or anything, you know? But I think that is like, if you feel like you need mocks, that is pointing to a bigger problem, rather than being like a standard part of my testing toolkit, if that makes sense. Like the first thing that I reach for isn't going to be mocked tests. It's going to be unit tests and integration tests and property tests and all these other things, snapshot tests. It's not going to be mocks. You could go on some tirades about how poor the testing is generally. Yeah, I'm sure. I feel like that's fairly common, especially in enterprise environments. Okay, the lib.rs includes a function called add that is tested in a module that only compiles if we're running tests. The whole module is gated based on whether test is set or not, which is something Cargo will do for us when running cargo test. The test attribute macro tests in Rust are regular functions if they return a result error or panic, the test fails. Since tests are regular functions, we can identify our test functions with the test attribute macro. Running cargo test produces pass fail output. Do I mention unit tests and integration tests up here? For authoring tests through the test attribute macro, if you're initializing, it will come with unit tests. Rust also supports integration and documentation tests natively. Okay, so we've got a library, we've got some tests, we've talked a little bit about testing. I don't think I'm going to go pretty deep into testing here. I'm just going to say that testing is built in. That's the important high-level note. When we do a chapter on testing, we can have chapters on, using Insta and unit testing and integration testing and doc testing and all these other things. Maybe in this case, we also mention examples very briefly. If we're going to talk about testing documentation, we probably also want to mention examples. You keep pretty light on testing to prioritize other earlier stuff. Yeah, I think the language stuff is the really important stuff. I also think the testing section would lose people very quickly, and it's getting pretty late in the content at this point. This will be like, 25, 26, 27 minutes into a 30-minute video. So people are already going to be pretty phasing out. I think ending with testing documentation and whatever means that, at some point in this video, when I throw it up on YouTube, I'm going to put out a call and be like, hey, this is going up on Rust Adventure. If you want the document, if you want things, if you want to read the output, go read it on Rust Adventure. And that's going to have to go like middle of the video. More approaches to testing are supported by the Crace.io ecosystem, including snapshot testing, table. Yeah. Good morning. How's the live going? It's going pretty good. I think it's about 11. Usually I go for maybe an hour more. I think since I've been going every day, I've been kind of trying to keep it a little bit shorter. But I think actually we are almost done with the first pass. And I would love to finish the first pass right now. So I'm going to do a small section on documentation. I'm going to do a small section on examples. And then I think these don't make it in. I think these get pushed. This is chapters, function signatures, type inference. I have to put this here. And here on line 1564 is the start of the deep dive chapters. Oh, wow. $8,000. You want to try to volunteer your friend to test this. He has anxieties that he doesn't know enough CS to navigate Rust. He's capable of it, though he just has the fear of the unknown. Yeah, I mean, if you think that your friend is a person who this would be useful for, I would love to get their feedback. I will finish a version of this PDF. I will post about it in Discord and on live at some point. And I will send you this PDF to give to them, and I will, like, the video will also be up somewhere, and hopefully I'll also have it like published on the website, so you won't need to like send them a PDF. But yeah. You've been telling him how much you love Bevy for a couple years. He's been a buddy I've been tinkering with game dev with for 10 plus years. Nice. That's awesome. Also, Bevy for a couple years is like, you've been using Bevy since like 0.6. I think Bevy's only hitting year 5, right? But yeah. I would love to have their feedback on that. And obviously, like, this content is, we've effectively done a first pass. I have to do an editing pass, a formatting pass, a couple of other things here, but this content is going to be like live content. When I get feedback from people, I will go back into this document and change things and republish a next version. So yeah, anyway. I think actually, because this is going to become so much content, I might also end up offering this as like an actual hard copy book, as well as all of the videos and all of the written content and all the other stuff. We'll see. The one thing I don't want to do is work with a publisher. So it would just be like a book for people who wanted it more than trying to get it into Barnes and Noble or something. Does Barnes and Noble even exist? Bevy was in the range of like 0.13 to 0.15 when you started and you didn't use it frequently. 0.13, so we're at 17 right now. We'll call it 3 to 4 versions a year. So it would be like 1 to 2 years ago, I think. You just adore it from a distance and appreciate their open source governance. Yeah. Bevy does a great job. I think Bevy does one of the best jobs of I've been around open source for a very long time. I think Bevy does a fantastic job in general. Could do it like the Crafting Interpreters book. What do you mean by that? I know of the Crafting Interpreters book. I don't know what you mean by that comment, though. Crafting Interpreter is something that I've been meaning to go through forever, though. One day. Yeah. So there's a version on the web like this. You mean a version on the web and then also a potential print copy and stuff like that? This is effectively what's going to happen to this document. This document is going to go on Rust Adventure. It will have a published version of it on the web. It will also, at some point, potentially have a like hard copy that you can buy because some people like that. I think it's hard for me to say that I'm not going to do that when the 30-minute video is 8,000 words and books are like 40,000. You know? I have a vision in my head of Rust Adventure being like a whole series of stuff where it's not just the workshops, but it's also like each of those sites that we were talking about earlier, like where it's like Bevy Adventure and, you know, Wasm Adventure and Leptos Adventure and like all these things are all just like books in the series on Rust. So I don't know. It's a lot of writing. It's a lot of work, but I am working towards it. I think it would be very cool. Is it going to contain a final project? The big version of the book might. So there's two things happening right now. One is that there's like a why Rust video, a introduction to Rust video, and then like the actual like Rust language video. Crafting interpreters? I feel like crafting interpreters is something you can buy, no? Bytecode, machine code. I guess you can buy the PDF, the ebook, read it on the web. They do sell it on like Barnes and Noble. So I don't know how they got it onto Barnes and Noble. I don't know if they have a publisher, etc. But it is a thing that you can buy from like bookstores. I don't actually have it because I've never had the time to actually do it. But I will buy it when I have the time to do it. I don't know how they do the print. It's 640 pages. Book depository, sample. I don't know. Yeah, you thought it was self-published is what you mean, yeah. You have no idea what the publishing process is like, but as a tech publishing consumer, you have opinionated opinions on it. You feel fancy if No Starch Press published a book I write? I feel like I wouldn't. I don't want to like be against any particular publisher or whatever, but like I just in general, the relationships that I've had with people who have wanted to distribute my content have not been particularly fruitful. And I think maybe if I was trying to get something into a bookstore and I didn't know how to do that on my own, and I didn't know how to, you know, like I I used to have a job doing InDesign work a long time ago. So like I do know how to lay out a book. But yeah, if I didn't know how to do things, maybe, or if like I wanted access to distribution, I kind of view it in the same way that like game development is kind of like a publisher relationship, right? If the publisher can give you something specific or is a specific kind of publisher, like a niche publisher, then those kinds of things can be useful. But just generally speaking, I wouldn't publisher by default, right? You started working on crafting interpreters using Rust. The process is very educational, especially for the first part when Java and used in the book. Yeah, it's like Java in the first and C in the second or something like that, right? I think a bunch of people have gone through it at this point, which is also cool because that means there's a bunch of repos out there that's like Rust crafting interpreters, right? First result is just somebody who did crafting interpreters in Rust. Like, yes, this is just like what they did while they were going through, but at least you have a basis for like what choices somebody else made, right? Which is super interesting. Exceptions versus errors. You use Miette, by the way. Miette's great. I love Miette. For loop versus iterator slices. Very big win for Rust, in your opinion? Yes. You don't have as much of an interest in those design aspects, probably. It could probably benefit a lot from valuable editor feedback since you don't have as much of an eye for design as like you seem to. I think that anybody could have those opinions. I've had histories where I've looked into typography and stuff. I think hiring somebody to do design work on your book could do you well versus working with a publisher, right? Like if you were somebody who wrote in LaTeX, for example, and you paid somebody to build you a LaTeX like scaffolding to produce a PDF that would get printed, I think that would be probably more value than working with a publisher to try to get that done. Because if you pay somebody who is skilled at it to do it, then you can have like a personal one-on-one relationship with the work that's being done. And you'll probably get a better result. So if your goal is to have like a well-designed book, you can pay somebody who knows how to design books. I wouldn't like go to a publisher and hope that they have like a well-designed book. Just looked and yes, it's self-published. There's an article where they set up their own company using their pets' names and how they, oh, sweet. I will, crafting interpreters, book publishing, pets name company, enter. Crafting interpreters is what I assume that post is. 3 years and 200,000 words. That's a lot of words. 0 to 353 pages. I bet you it's on the same 353 pages. Perfect. 2014. 2020. These are things that I am going to read off stream. Absolutely. This is very interesting to me from that perspective. 200,000 words feels like a lot. I do have game programming patterns. Game programming patterns is like over here somewhere. Maybe it's in my other book pile. I have piles of books. there's a book pile over here. There's a book pile over there. There's just, you know, who needs shelves? Book piles are where it's at. Yeah, game programming patterns is the other article. Okay, cool. You should have piles of books. Yeah, I have piles of books that I just leaf through as I walk past, basically. Okay. That said, we are already at just for the content that we've written in the last week, we're currently at 8,000 words. 7962 right now. So that's half a year to produce the same amount of content, just from a production perspective, not from an editing, not from anything else. That is half a year's worth of work if I continue at the current pace. Assuming that it ends up being something as big as crafting interpreters, which I don't know that it will be. What are the books that every software dev should take a look at in your opinion? You mentioned game programming patterns. Any other suggestions? I think it depends on what area that you're interested in. Personally, I've read a bunch of books. I have read a bunch of the books that people suggest. I think that there's a lot of books that are like commonly suggested as like, oh, you should go read. I don't want to mention any specific book. You should go read this specific book on game programming patterns or whatever. Not game programming patterns, but like design patterns for how to write code. And like a lot of those books are reasonable to skim. Like you don't really need to read them front to back, and a lot of them are outdated material too. Like a lot of the quote unquote classics like really don't apply in the same way to modern languages. I think one of the ones that had the biggest impact on me was 7 Languages in 7 Weeks. This was really interesting because, like I was saying somewhere earlier in the stream, this is basically like a mini tutorial for each language, right? And there's 7 languages here: Ruby, IO, Prolog, Scala, Erlang, Clojure, and Haskell. I think of these languages, I ended up doing work in Erlang, Clojure, and Haskell. IO really helped open my eyes about JavaScript. Prolog is interesting, but I don't really have tons of use cases for it. But you'll find a lot of people like build small Prolog interpreters for different things. Ruby, I didn't end up getting into at all, but was still interesting to read about. I think that exposing yourself to a number of different languages in like a little bit for each of them was really cool. That author loves some functional programming, Bruce Tate. I think they do other programming stuff, right? Wow, 2022 he did an interview about that book. Interesting. Yeah, now he's working on programming Phoenix Live View. That doesn't surprise me at all. Lisp wasn't, yeah, Clojure is a Lisp. Clojure is Lisp. Clojure is specifically Lisp on the JVM. I was a fan of Clojure for a while. I don't love working with the JVM. I think that's what kept me away from Clojure in the end. But I definitely did some web work with Clojure in the past. I don't know that this is still the package manager, but Leiningen, which I could never spell, literally. I guess there's a new depths thing as of like 2 years ago, but Leiningen was the dependency manager that I was using. Clojure script was really interesting. Let's see. I missed a couple comments while I was doing that. Definitely agree on it depending a lot. The tech industry field is so wide, it's hard to guess what's relevant for someone. Absolutely. I think there's a lot of specific niches. There's a lot of books that cover specific niches, and there's no way I'm going to know all of them in the same way that I'm not going to have expertise in every area. You like the style of book. The first time you learned about new type pattern in Rust and parse don't validate, it opened your eyes on a lot of aspects of language design and added more appreciation. Yeah, parse don't validate is from a Haskell person. This is this is like Haskell. So one thing that I'll say is Haskell probably a pretty non-industry relevant language for the most part. It's fine. It works. It is very interesting from a language perspective. It will change in some ways the way that you think about things, which is really cool. If you can get through the learning process, if you can get through a lot of the cruft, there's a lot of interesting things about Haskell. And a lot of takeaways where if you don't go overboard and try to like re-implement Haskell in another language, there's a lot of takeaways that you can actually take back to other languages. For example, Rust map, Rust. Let's go for option. So map obviously is a function on iterators, right? But map is also a function on option. And map is a function on result. And map is a function that you can put on pretty much anything that contains a value. And the idea for that is not hard-coded anywhere in Rust. But if you look at the functor in Haskell, that's what this is. It's something you can map over, right? This is a function from A to B where you take it and you get f of b, right? So this gives a name to that thing. And while Haskell has a specific like type system level and syntax level operation for it, Rust kind of just takes that and is like, oh, this is a practical idea. If you have a container like an option and there's a value that could be inside of it but could also not be, then you can map into it. Right? The functional styles of programming didn't click for you as well, but you're very glad you learned Erlang because functional programming increased your comfort with recursion a lot. Yes, that's definitely true. I think recursion is a huge functional programming thing. Where can one find a good idiomatic Rust tutorial reference without using crates so that one learns the language and not just libraries? That's what I'm building on stream today. Just had to learn recursion to be good at recursion. Just had to learn recursion to be good at recursion. That's what I'm working on stream right now. So I'm going to release this fairly soon. Hopefully I'm going to get this video actually done this week. I want to try to get it released. I know that it's getting late in the week. So we'll see what happens because I have other video work that I also need to do. But that's what I'm doing here. This is all this content is going to go up on Rust Adventure. That is where the introductory Rust course that I'm going to point people to is going to go. You program in Kotlin and Java at your day job, and a lot of the patterns you learn in Rust don't really work without move semantics, so you feel kind of homesick when you use another language now. Yeah. I think if you find a language that works really well in certain cases, it's hard to go back to languages that don't. Specifically, if you find a language that uses algebraic data types, so sum and product types like structs and enums, it's hard to go back to a language that doesn't have algebraic data types, right? It's hard to go back to a language where you can't have an enum that contains some other data. It feels crufty. It feels hard to work with. Not that there's anything wrong inherently with not having them, but they're just such nice tools. Kotlin has sealed interfaces. It's kind of the same. Cool. I haven't written much Kotlin at all. It was kind of still Java when I was doing Android stuff, so I never really got into Kotlin. Okay, we covered testing, Rust documentation. Rust comes with documentation tools built in. Running cargo doc on the library we just initialized. Produces the documentation that was written for all items as a web page. Right, cargo doc. I guess we'll do cargo doc open and then like start talking about this and like including some screenshots of like this. By default, this doesn't include a whole lot of content. You can turn on a lint to alert, to warn when documentation isn't written for an item. You've been watching your videos in bits and pieces mostly. Thanks for all your effort. Why don't you create shorter clips of your long videos for particular subjects, like 15 to 45-minute video form? I started kind of doing that with shorts. I don't know that the shorts that come from the streams are super useful, but I can keep trying to produce them. The answer for why don't I do like shorter videos rather than live streams is I do shorter videos. It's just the creation mode for the two things is very different. So I can jump on stream for 4 hours. People can ask me questions. I can answer, and I can do a bunch of scripting, or I can write a bevy example or whatever. If I do a specific video, I have to have done all that research anyway. So in my mind, streams lead into videos, lead into workshops. And that's part of the reason that I'm on YouTube at all, right? Because a lot of the more experimental stuff or stuff that doesn't fit on Rust Adventure as like a polished workshop or a polished course or whatnot, I can do experimental stuff. I can go like do a video on JJ next week, or do a video on some new Rust crate, or experiment with some light maps like we did, yesterday or the day before. And eventually that stuff makes it into polished content, but there has to be a place to start, right? And that's what live streams are in some sense. Can you mention that cargo doc also includes dependency docs too by default and doc tests? We mentioned doc tests in the testing section. You like the format used by the green tea coding. I don't know anything about green tea coding. I'll look it up later. Have I tried Typist? Have I tried Typist? Have I tried Typist? This is Typist. This whole thing is Typist. This is about 36 pages of Typist content at the moment. So this is main.typ. This is a Typist document. We also experimented with rendering Typist to HTML last week, which is really cool. I think I'm going to start writing blog posts and Rust Adventure articles in Typist. I just need to finish up some of that work, but it's very exciting. I love Typist. It's awesome. Rust comes with documentation tools built in. How did we frame this for testing? Running cargo doc in the library, we just produces the documentation that was written for all items as a web page. What is the missing docs, right? This is a Rust sealant, right? If I remember correctly. Why does that not produce an error? Oh, this isn't the same. Okay, hang on. I need to put this in the right project. Unless I lint to over lints.rustc. Is it not rustc? It's Rust. Lints.rust. So we'll grab this output. I think this has to be kind of, I don't know. I don't know if it needs to be an image. In our recent testing ground, create open cargo.toml and I guess it's not enabling the lint, right? It's Rust lint denies compilation if docs aren't written. Then when running tests, well, we don't have to say deny here. We could say warn, which might be more palatable to people who haven't worked in this way before. Right? I think for me, a library is basically useless if it doesn't contain documentation. But I can definitely see arguments for people who would prefer to work and develop with just the warnings. The comment didn't age well even for a few minutes. You want to get back into creating some nerd content. You think you want to make some YouTube video tutorials on learning digital logic design using games like Turing Complete. That would be sick. That sounds great. Writing documentation is always your bane. Why is it your bane? What's the blocker for you? Is it just that like you don't feel like you know what to write, or this is going to be worn? Open. This is a crate level documentation. There's documentation about that. We're not going to go deep into like how to document things, but maybe we'll include an example here. We call this testing ground. Ground. Cargo test. One doc test. Cargo doc open. Shows the example. Perfect. You're just bad at knowing what to write. Yeah, there's always the question of, am I writing something too basic and obvious? I think the answer to that is you can really never be too basic and obvious. Documentation is there to be the ground truth for somebody that's going to use the thing that you built. So if there is a thing that you have assumed about the library that is basic, you can definitely write that you assumed that thing. And that is not too basic, right? It's easier to some extent with a library. You document everything you want the user to use and all the arbitrary knowledge they need to know your library. Yep. You can always spend an entire day writing documentation, right? I mean, writing it like, there's a bunch of different ways to do development, right? And one of the ways, if you're doing a library from scratch, brand new, is you could write the README and the examples for how you want somebody to be able to use it, and then try to build the project with the documentation towards that goal. You know, it's not something that works for every project, but it's actually pretty cool to take a user-centered focus on that and then build that documentation up as part of building the library. You have sometimes with critical projects at work, you'll have docs in a project just to share document code organization and layout so people know where to look for stuff. Yep, absolutely. Writing docs can feel daunting at times. Some of the best case to write tests If a method assumes something about the surrounding context, yes. Tests are great. Tests and documentation definitely work together. Putting this in docs plus asserts can make the life of the dev team a lot easier. Yes. And in the example that we just wrote for a demo, right? This is a way that we expect add to be used in the wild, right? So if this use case breaks, Rust runs the doc tests and will tell us if that use case breaks, which is very, very, very cool because now it's documentation and it's tests. Documentation using crate and 3 slashes for items. Here we've also included an example in the documentation, which is compatible with Markdown. Content is written using Markdown syntax. Here we've also included an example in the documentation, which gets compiled and included in the tests that run, ensuring that our documentation is never out of date. It just doesn't feel right to me sometimes. Like if it's something really simple, like a function that adds a trailing new line, there isn't much to say for the documentation other than that. Why is it adding a trailing new line? Right? Like this function adds a trailing new line, sure, but like why? What is it supposed to be used for? Right? Like sure, I can add a trailing new line myself, or I can use this function, but like why does the function exist if it just adds a trailing new line? You know? If you're producing a certain kind of document that needs trailing new lines, then say something about like new lines are important for the document because we use them in X, Y, and Z places, and thus we want to always have it consistent, right? I don't really agree with that, honestly. I think if you have a function, right, and it adds a trailing new line, why is it adding a trailing new line? Right? What's the purpose of that function? Why do you need a function to add a trailing new line? Right? Why did you abstract that? Right? I think there's a balance between like here's a little helper function that does a specific thing. Why is it worth putting into a function? Right? Because like adding a trailing new line is something that you can just do at any point in the code. You don't need a function to add a trailing new line. So why is it a function? Why do you need Markdown compatibility? Isn't typist style better? You've been learning typist for the last month or two, so pardon your lack of knowledge. The issue is that Cargo, or like Rust, right? Rust predates typist. And this is a Rust source file. So the reason that Markdown is supported here is because Common Mark and the Markdown spec has just been around and stable longer than typist, right? If they used typist for the documentation here, for the like the add function or whatever, right? Then everybody would kind of have to update their documentation every time typist updated. Yeah, and us like if the documentation for the function is so trivial that you don't feel like you need it, why does the function exist? You think that for that example, adding a new line was just an example of an easy to understand function, right? But that's what I'm saying. Like if you have a function that does a thing that isn't substantially adding to the value of the program, I also think that there is a case for that function existing, and thus the documentation for that function is why does this exist, right? Because you look at that function and you're like, oh, this adds a trailing new line. Why do we have a function that adds a trailing new line? I know how to add a trailing new line, right? Like if I'm here and I'm like, okay, I want to add a trailing new line to some like string, right? Am I going to use print line? Probably. Rust starts with feels pretty obvious. What do our docs look like for that? Rust starts with. Starts with. So documentation here returns true if the given pattern matches a prefix of this string slice, right? False if it doesn't. What can the pattern be, right? Pattern can be a string slice, in which case the function will return true if the string slice is a prefix of the string. Pattern can also be a character, a slice of characters, or a function or closure that determines if the character matches, right? So are you seeing how like starts with can accept, you know, n different kinds of arguments, and thus this needs to actually be documented? Like, what does it actually accept? How can I actually use this? And if it doesn't, it's the opposite direction, right? Why doesn't it do that? Sure. So you can make an argument that the type signature should tell you everything that you need to know, right? That is an argument that people make. That is an incorrect argument for people who are new to the domain, right? Just starting out. Like if there's a person who is not sure what your code does, making them assume things about, like making them read all of the type signatures and understand all of the type signatures to figure out how to use that function is the wrong approach. But we can do that too, right? Starts with self, pat, whatever. It's on string slice. So it's a string slice. We call starts with on the string slice. We give it a pattern. A pattern has to implement P, has to implement the pattern trait, which is one of these. And then we go in here and we like have to figure out how to construct a pattern. This also has more documentation on it, right? But like this is, we end up having to get here like, okay, so what implements patterns? So there's a pattern for car, string slice, reference to string, reference to a slice of car, reference to CB string. What is CB string? You know, et cetera, et cetera. Well, the device entity repository. Did I miss a comment before we dove in here? Let's see. Yada, yada, yada. To continue discussion on the Markdown compatibility issue, can a tool be used to convert Markdown to Typist in future, or are there edge cases and compatibility problems similar to LaTeX? I think Typist hasn't hit 1.0 yet, so you can expect the format to change for a while. That's all that is. Theoretically, if Typist decided to lock down a 1.0, it could be used. At that point, there's other discussions to have, but there's nothing like inherently preventing Typist from being used like that. The Rust project just had to pick an option, and they had to pick an option in like 2014 or something like that, right? So unless you want to wait a decade for Typist to exist, you have to pick something. In the project you're working on, the worst comments are for injected beans. It would be something like the device entity repository. Yeah. You're not saying the function signature should be enough. That's too much of a stretch. You get lucky when those happen, IMO. Yeah, and also like that's more true in places like Haskell, which are very specific with their function signatures. It's not as true for very like generic functions is the wrong word, but if a function takes like an owned string and then it could do anything with that, right? So the function signature doesn't really tell you what it's doing. The type argument is more complex, what starts with, so it makes sense to mention something like it can be string, slice, or car, etc. Yeah, but that's what I'm saying. Like, there's very few situations in which you're like, there's no documentation to write, right? If you're ending up with a bunch of functions that are like the new line example, and all you're writing for them is this appends a new line, I think you're thinking about it contextually the wrong way, right? If you have a function and all it does is return like the thing with a new line attached, like why does it do that? What is the purpose of this being a function, right? Is there a reason I shouldn't do this manually, right? That's part of the documentation. Is appending a new line myself problematic in some way, right? Can the thing that I write for a new line somehow have a different effect? Could I accidentally be allocating when I shouldn't be allocating, right? Et cetera, et cetera. Like, do you have like some optimization in it? Like why does this function exist, right? And I think that's true for pretty much everything. So for me personally, deny missing docs is the right choice. I appreciate that other people might not like agree with that or like that workflow, which is totally fine. But for me, deny missing docs is definitely the right approach. Let me go through this for a second. Testing, yada, yada, yada. Cargo test produces pass-fail output. More approaches, documentation, built-in. Cargo doc on the library we just initialized produces the documentation that was written for all items as a web page. By default, this doesn't include a whole lot of content, but you can turn on a lint to warn when documentation isn't written for an item. In our recent testing ground crate, open cargo toml and add a Rust lint that denies that warns when compiling if docs aren't written for items. Let's make this documentation. Isn't written for items. Then when running cargo test, cargo doc, or similar commands, missing documentation will generate a warning, and then we show the warnings. This shows warnings for missing documentation for the crate itself, as well as the add function. We can add documentation using // exclamation point for the crate and // for items like the function. Content is written using markdown syntax. Here we've also included an example in the documentation, which gets compiled and included in the tests that don't run, ensuring that our documentation is never out of date. Yada, yada, yada. Show a image here. Then we're down to examples. How are we doing on time? 10 minutes. Yeah. You agree with the workflow, just something you're terrible at. I think it takes some practice to kind of contextualize it. I think that it can also be like, if you're a person who's in a specific kind of flow state and you don't want to write the documentation because you're like in a flow state writing the actual code, that's cool. I think these are things that you can change for sure. But you know, not everybody needs to work the same way. Your perfectionism starts to get to you when you have some docs and you generate the doc site and items are missing documentation feel unprofessional and untrustworthy to some extent. Yes, absolutely, as it should. Right? If there is a library that doesn't have any written documentation and only has type signatures, I'm going to think that that person didn't like put in any effort to document it. So why should I use it? Right? I wouldn't necessarily use the words unprofessional, because I feel like professionalism is kind of one of those words that's just levied at things you don't like, if that makes sense. So unprofessional isn't the word I'd use, but like I might not use a crate if it doesn't have any examples or documentation, and it's just like code in a repo and the bare minimum cargo doc, right? If you want users, you want to try to engage with people, especially the people who are interested in trying to use your crate. Yeah, opening the docs gives you the point of view of the user, which highlights where I was lacking in docs. Yeah. And right, like you can just have that running, right? You can have cargo watch, cargo doc open or something like that. And the web page can just keep updating. Which is totally valuable. It's basically the same thing I'm doing here, right? If I was writing like little code, I'm writing code snippets, I'm testing them, I'm including them in the doc, and then like this is the documentation, right? If you think about it like that, I'm literally like live viewing my documentation at any given time. For some reason, the Typist website doesn't open for you. Is Typist down? Typist might be down. It's not opening for me either. Maybe something went wrong. Interesting. Maybe they're doing a port or something. Hard for me to check on stream because I'm not going to open Discord or whatever. But Typist is great. You should check it out when the site's up. Okay, let's try to get for examples. You were willing to try it? The site is down. They lost a user. Examples. Right, fn main, whatever. Use testing ground, add, you know, let number equal add to 2, assert equal, you know, number equals 4, something like that. And then we need, I think, 2 documentation comments, right? This example shows how to use the add function in the context of a standalone application, right? And then we don't actually have to put it on main, right? Yada, yada. And then there's that, it's a nightly flag, so I don't know if I want to mention it. Cargo doc include examples. That's not the not the thing that I want. There's like a nightly thing where, for example, Bevy runs with it. If you look at like Mesh 3D or 2D, why not 2D? If you look at Mesh 2D, you see examples found in this repository. There's a thing that goes and scrapes the examples and dumps them into the docs. Which is really, really, really cool, because then you're effectively writing documentation for all of these examples and all of the usages that you have, etc. But I think there's a nightly flag or something like that. Did I forget to close some here? Does this close because I have the documentation written like this? Hold on. We gotta debug a piece of Typist. 1642. So this is the issue. I think it's going to be because of this documentation, right? Yeah. So the question is, do I need to put a slash here for this to... It's pretty rare that we run into typist issues like this. Okay, so I'll go back and check this and make sure that this has the right output and everything. This is in testing, right? Testing. No, it's in docs. Docs. Missing docs. Yeah, so this is the issue there. Can I take a different approach? Does this support doing 4? Seems like it. Testing, documentation, perfect. We'll use 4. So commonly in Markdown, if you have things like this, where you basically have an example that has like an example inside of it, or like a nested code block, and you still want that to be treated like a regular whatever, you can do 4 ticks instead of 3. And thus the start of the code block is the 4, and it'll look for the 4 at the end instead of the 3, which gets rid of all the parsing issues. Cool. Examples. Where is our... cargo run example ads. This runs, doesn't do anything. It's fine. In a new file, in examples ads.rs, write a new program that uses the library, the testing ground library. Rust. We've talked about documentation, so I include some documentation there. This example can now be run with cargo run example ads. Example flag. The example is named after the file name by default. And we do cargo test. The example's compile check. But I don't think there's any output here to tell us the example's compiled checked, right? So we just kind of won't mention it. The examples directory is a very common feature in Rust projects. Show real world usage of libraries. You can always get the Redis package from GitHub and use in your system. Yeah, you can brew install typist or whatever too, or cargo install typist. You don't need the site, but yeah. Not suggesting a change, just being pedantic, but the comment describing / exclamation point versus / was a little different than how I think of those as document previous thing and document next thing. Yeah, the explicit terminology for them is inner comment attribute and outer comment attribute, I think. This is an awkward you buy situation that we're in over here. What is going on there? Don't know what's going on, but you know what would solve it? Another desktop. What was I doing? Inner, outer. Line docs. Let's go with this. Line comments that begin with // exclamation point are dot comments that apply to the parent of the comment rather than the item that follows. Yeah, inner line doc, outer line doc is what these are called. A bit off topic, but if you were to suggest a laptop for Linux or FreeBSD, which one would you suggest for heavy compilations? I actually don't have a suggestion. I don't run Linux on laptops, haven't for a while, so I don't have a good suggestion. Somebody in chat might have a good suggestion. I think if I was going to try to get a new computer, my computer would probably be a framework, but I don't have, like, I can't suggest this to someone because I don't own one. But these fundamentally are super interesting to me. Dynamically configurable, you can throw GPUs in them. But I don't have an answer, unfortunately, for the laptop thing. Balancing discussions of nuances and docs for newbies is hard stuff. Yeah, absolutely. It's also like, it's counterintuitive because I think by default, people want to kind of operate in a way that proves their knowledge, right? If you don't include something, you're kind of like, I don't know it if I didn't include it. But realistically, you can very easily overwhelm somebody by including too much context. And people who are beginners don't have a lot of capacity because they're already learning all of these other things at the same time. So introducing too many additional notes can be very disorienting. You've run Linux on laptops for a long time. You've had the best luck with Dell's Latitudes, honestly. Dell Latitude. So one of these. You got a System 76 and been very unsatisfied with its reliability. That's really unfortunate. System 76. That's super unfortunate. The book can very quickly turn into a textbook if not careful. Yes, absolutely. It can very quickly turn into that like deep dive thing that we were talking about before. Which is why I came on stream today and I was kind of like, okay, well, the struct, the primitives, the scalars, like that section is very syntax heavy. So I think I wanted to claw back some of that higher level with the tail end of this. You can always separate documentation for advanced users and beginners. Yeah, it requires a lot of time. That's kind of what I'm doing. So this is the beginner stuff that we're going over right now, actually. Which is why it's not terribly depth, right? It doesn't have a lot of depth to it per se. It has a lot of like, it touches on a lot of different topics, touches on the high level reasons for topics, like why ownership, what can it do for you? The fact that Rust is an expression-based language, etc. But it doesn't dive into like, there are 4 kinds of ranges, inclusive ranges, exclusive ranges, you know, whatever, infinite ranges. It doesn't dive into the 5 kinds of like iterator traits, like iterator, into iterator, double-ended iterator, Rayon's extensions, Iterators extensions, like et cetera, et cetera. So yeah, I don't know. It's tough to pick the right scope for sure. But I think that this is doing a pretty decent job already, and then we will have the additional deeper dives as we go through this. And I've written a lot of content like this before, which is why it flows a little bit easier. I'm trying to come up with new stuff from scratch rather than relying on old content that I've written, because I know a lot more now than I did then, if that makes sense. But yeah. Finally, Rust includes support for examples in a new file, testing ground, blah, 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 ads. I guess a little note here at the end that's like, for the overview of the Rust language, there's a lot that's been left out in the interest of keeping it short. Or to the deeper introduction to the Rust language. Content, if you decide to move forward from here. I'm gonna reframe that, but basically that's it. We've finished our prototype set of content for the Rust language stuff. And we came in at a cool 8,500 words. Which is only 56 minutes of content. Okay, cool. I'm a bit over time. Let's see, 200, your laptop doesn't power on at all. That's unfortunate. Currently using Latitude, can't complain. Fingerprint reader does not work, but you have to expect such things with Linux. Yeah, fair. You've had good and friendly support from System 76 though, so I want to give them some positivity on that. That's sweet. That's always good. That's it for a stream for today. I will put up a scheduled stream for the next time that I go live. It'll either be tomorrow or Friday morning. I may use tomorrow to just do a bunch of video production rather than stream. I haven't decided yet. But thanks everyone for hanging out. That's about it for today. And I'm going to try to get this video out soon. So look forward to that. I'll see y'all in the next stream.